So we want to talk about various forms of the exponential and converting between them. So there's really three forms of an exponential function you'll see, and you could have the same graph written in any of the three forms, but we typically use this form when we want to talk about the base. We use this form when we want to think about it as compounding continuously, and we use this form when we want to talk about compounding interest. So really we go back and forth between a times b to the t and a e to the kt more than the other ones. But if we were going to look at how to go back and forth, a is the same no matter what on both of these. But the key here is to realize that e to the k times t is the same as if I took e to the k and raised it to the power t. So that means b is the same as e to the k. So for example, if I have e to the 3t, to rewrite that as b to the t, then I would use b as e to the 3. If instead I had 3 to the t, to rewrite that, I'm going to have to use the fact that 3 is e to the k. Remember, e is the number 2.718, etc. So I would use a natural log to solve for that, and we'll talk about logarithms more in the next little bit. Sorry, natural log of 3 is not 3, it's going to be some number. So we'll talk about logs some more coming up. To go back and forth between a b to the t and a 1 plus r over n into the t, this doesn't happen very often, but the key here is to realize b is 1 plus r over n to the nth power. So you can find b easily. The reverse is a little bit harder, and we don't do that very often.